welcome to my channel. Here I have a very special question to solve on the construction of ellipse. I'm going to read the question 2 times and then we go on and look at how we can solve a question like this. Okay, so the question says 2 points F1 and F2 located on a horizontal line are 90 millimeters apart. A third point P moves around both points, tracing a path, such that the sum of the distances from both points is a constant and equal to 120 millimeters. Plot the locus of point P. I will take the question again. 2 points F1 and F2 located on a horizontal line are 90 millimeters apart. A third point P moves around both points, tracing a path, such that the sum of the distances from both points is a constant and equal to 120 millimeters. Plot the locus of point P. All right. Let's go and see what we are to do with a question like this. So what we are to do first is to draw a horizontal line. So here we have a horizontal line, and then we are going to draw a vertical line. So here we draw a vertical line. So we have this. Okay, now we are told that the 2 points are 90 millimeters apart. Point F1 and F2, they are 90 millimeters apart. So we are going to divide that 90 by 2, and that will give us 45. So that will give us 45. So we take a measurement of 45 millimeters on the ruler with the compass. Okay. Then before that, I want us to label the point of intersection of these 2 lines as point O here. So, okay, here we have point O. So we have taken 45. So put pinpoint here. Okay. Then make an arc on this side. So make an arc here on this side of the horizontal line, and also make an arc here on this side of the horizontal line. So this gives us point F1. So this is point F1. So and then here we have point F2. So we have the focal point F1 and the focal point F2 of the ellipse. Okay. Now the next thing that we are going to do is to locate the vertices of the ellipse. The vertices of the ellipse. Okay. Now as we are told that the sum of the point P from F1 and F2 is equal to 120 millimeters. So what that means that the major axis of the ellipse is 120 millimeters. The major axis of the ellipse is 120 millimeters. So what we are to do now is that we take a measurement of 60 millimeters, which is half of 120. Okay. So take a measurement of 60 millimeters, which is half of 120. Then we put the midpoint here at point O here, and then we make an arc on this line. Okay. Okay. So make an arc here, and then we also make an arc here. So these 2 points, so this point, let's call it, this is point A. Okay. And this is point B. So these 2 points A and B, they are the vertices of the ellipse. Okay. Now this 120 that we have used to locate this 60, the 60 that we have taken, we took, which is half of the major axis. So this 60 that we have taken, which we used to locate point B and point A, so we are going to keep it because we are going to make use of it to determine the minor axis of the ellipse. So with this 60 millimeters, put the pinpoint here on F1, and you can also make use of F2. So make an arc up here on this line. Okay, and make an arc here down on this line also. Okay, so this point here, this point and this point. Okay, so this point, we call it, this is point C, while this point I will call it point D. So this line CD, so this line CD is the minor axis of the ellipse. CD is the minor axis of the ellipse. So that is how to locate the point as I've done it here. Now, the next thing that we are going to do, when you have a question like this, it means that you have to make use of arc method. That is what we are to use. So what we are going to do now is that we are going to divide line OF1 and OF2 into a number of equal parts. I will divide it into 4 equal parts. So this is how I'm going to do it. So I'm going to draw a line from point O. So from point O, I'm going to draw a line. So we draw a line from point O in this direction, and I will also draw like this in this direction. I believe you know how to divide a given line into a number of equal parts. So as I said that, I'm going to make 4 equal points on this line. So this is 1, so here is 2, this is 3, and then this is 4. Okay, then we also take from here. So this is 1, 2, 3, and 4. So we have this. All right, so we join the last point with point F3 here, and last point here we join it with F1. Okay, and then so we are going to draw lines that are parallel to this line from each of the points. So we set the set square along the line, support it with the ruler, and we shift to the next point. So we draw this. Okay, and then so we shift again. So we draw this, and then so we shift again and we draw. All right, so we have this to next. So we set the set square along this line like this, and then so we support it with the ruler, shift the set square to the next point here. So here we draw this, and then we shift to the next point and we draw. Okay, then we shift to the next point, so we draw. Okay, so we have this point. So next we are going to number this point. So this point here, I will call it is point 1. Here is point 2. So this is point 3. Okay, so I'm not going to number this one. It's already the focal point. So this one I will call it 1 prime, and this is 2 prime, while this one is 3 prime here. Okay, so we also leave this one. Now, having done this, the next thing that we are going to do is that so we take the compass, so we put the midpoint of the compass at point B here, and we extend the pen point to 1 on the left side. So B to 1 on the left side here. So we take this radius or this distance, okay, with the compass. Okay, take this distance and raise it up like this. So then put the pinpoint at point F2, put it at F2 here. So you make an arc, so up like this, and make it down here, and then with the same radius just turn like this, put the midpoint at F1 and draw an arc up here and draw it down here. All right, so next, so from B again to point 2, from B to 2 on the left side, so we take this distance like this. Okay, so we have this distance, and then so raised up like this, put the midpoint at F2, put it at F2, so draw an arc up and draw an arc down here, and then so here we take it to F1, so we draw an arc here like this, and then we draw an arc down here, and then so from B again to 3 on the left side, B to 3 on the left side, so we take this distance. Okay, so B to 3. Okay, so we take this distance and we raise it up like this, so put it at F2, put it at F2, so draw an arc up, and then so draw like this, and then so put at F1. Okay, at F1, and then so we draw an arc here, and then we also draw an arc here like this. All right, so I made use of this point 1, 2, 3 here on the left side of the major axis. Then from B now to 1 prime, from B to 1 prime on the right side of the major axis. So B to 1 prime, take this distance, so raise it up like this, put the midpoint at F1, F2, then make an arc here on the first arc, so make it also down here on the first arc, then take it now, so bring it to F1, bring it to F1, the same radius, so draw an arc up, so draw an arc down on the first arc. So next, from B to 2 prime, B to 2 prime here, so we take this distance. Okay, so then we okay, so we raised up, so put it at F2, put it at F2, make an arc on the second arc here up, and make it down here. So with the same radius, pinpoint at F1, make an arc here on the second arc, make it down here also on the second arc. Then the next one is to point B. Okay, so we extend it to 3 prime. Okay, so we take this radius and raise it up, put at F1 here. So sorry, F2. So make an arc here on the third arc, make it here on the third arc. So take it now to F1. Okay, so make an arc here on the third arc, make an arc here on the third arc down here. So all these points that we have gotten, we are going to make use of this point. We are going to join them together to obtain the ellipse. Okay, that is the path traced by point P, okay, around point F1 and F2. Okay, we are going to make use of the French curve. Okay, so that's what we are going to do right now, having located this point. Okay, so what we have to do now, so with the French curve, so we set the French curve along the point, okay, as we have it here. Okay, we are going to join the point together, so it goes like this. Okay, it goes like this. All right, so we have this, and then so I'll turn to this side. Okay, all right, so we join this point. All right, so we have half of the ellipse. Then we turn to this side, like this. Okay, and we join this point together, point D like this. All right, so then we turn to this side. All right, so we turn to this side, and then so we also do the same thing. Okay, so set French curve very well along the point, and then all right, so we have the points joined together. So we have formed the ellipse as we have here. We have formed the ellipse as we have here. Now, I want to add something to this particular question that you may be required to do. That is, you may be asked to construct a tangent and a normal to a point on this curve here. Okay, so let's assume that the question says that we should construct a tangent and normal at a point 30 millimeters above the major axis and on the right side of the minor axis. 30 millimeters above the major axis and on the right side of the minor axis. So what are we to do with that? So we need to take a measurement of 30 millimeters. So we are taking 30 millimeters. So from just come to the center here to point O here. So take 30 millimeters of this is 30 millimeters. Okay. So here we have 30 millimeters. So now, so what you have to do now is that, so with the T-square, so just draw a horizontal line from this point to touch this curve here. Okay. So this point now, where the horizontal line touches the curve, so this is where we have point P here. Okay. So I'll just put P here. Okay. So this is the point that is moving. Okay, so now, so what you have to do is that join PF1. So join PF1 with a straight line, join PF1 with a straight line, and then you join PF2 also with a straight line. Join PF2 with a straight line like this. Okay, so we have this now. All right, so the next thing that we are going to do is that we are going to bisect the angle between PF1 and PF2. So put the pinpoint of the compass here, and then so draw an arc like this. Okay, so then we put the pinpoint here where this arc touches PF1, put the pinpoint here like this, and then so extend the pinpoint and draw an arc like this. So with the same radius, put the pinpoint here on PF2, so draw an arc where the arc touches PF2, so draw an arc like this. So what we are going to do now is that, so from the point of intersection where the two arcs meet, so draw a line through this point and then draw it through point P like this. So this line, so this short line that we have here, I'm going to make it a thick line, and this short line is what we call the normal line. So this is the normal line. So now we have to draw a tangent to the normal line. That is a line that will be at a right angle to this line PQ. So what we have to do, so a normal is at a right angle to the tangent. Okay, so we take the protractor. I usually use my protractor here. So set the protractor here on the line. Okay, so let the 90-degree line, so let it be on line PQ, and make sure you can see a little point on the curve. So that is a little part of point P. So just draw the line. So draw it like this. Just draw like this. Okay, so this line, let's call line RS. So this is point R. Okay, so and this is point S on the line. So this line RS is the tangent to the curve. That's simple as I've done it here. All you have to do is to practice. Or in practice, you become a master at this work. Thank you. Keep on practicing, and God bless you.